Hey guys, it's Mr. Katz. I just wanted to run through the two problems that we did in class in case you needed a little more explanation than what you got with your partner group. The two problems, this was one of them, and there was another one that looked just like this. So we're going to do this one first. So in order, do me a favor, and if you're having a little bit of trouble, pause the video, go back. You can watch this as many times as you want, but I'm hoping this really helps you just get in the habit of going through the process of what you do in the procedure to solve an equation. So here, we're going to first distribute, because that's what we always do in an equation first. And I'm going to bring down everything else. Now here, I could bring this down, but since we know we're going to distribute with our next step, I'm going to go ahead and do all the distributing and bring down everything else. So the next thing we're going to go ahead and do is we have a couple things. Before we start moving things over, we have things to combine on one side. Here are two numbers, negative 16 and positive 7. And when you combine them, you can get a negative 9. So I'm going to bring down my 2a right from there. Bring down my equal sign. Now I have a 5a and a negative 3a. So together, that's 2a. Positive 10, negative 19. When I combine them or add them, 10 plus a negative 19, you get negative 9. Now, at this step, at this point, you might notice that you have exactly the same thing on both sides of the equation. So that should kind of tell you that really, if I'm going to multiply any number times 2 and subtract 9, it will always equal that same number multiplied by 2 and if you subtract 9. So at this point, you should realize that there is anything that you could put in for a to make this equation work, which means that there's anything you could put in for a to make this equation work. But let's go ahead and solve it just so you can see what it looks like as you go back to go to the very end. So I want to move all the a's so that we have them on the same side of the equation so I can later isolate them. But when you do that, both a's cancel out to get 0, and you're left with negative 9 equals negative 9. And we talked about that when your variable totally cancels out, you're left with, you have to figure out, is that a true statement or a false statement? And negative 9 will always equal negative 9. So since it's true, we know that the answer to this is all solutions. So it's not that a is something very specific like the number 2 or 4 or negative 5. You could really put anything in for a. And this side of the equation will always equal this side of the equation, no matter what you put in for a, as long as every single thing is the same a. The next problem, there's a lot of ways that you could have done this. Because I have a fraction here of over 2 and a fraction here of over 6, I'm trying to get rid of both those denominators. So I'm going to pick a multiple of both 2 and 6. And when I multiply 2 times 1, you get 2, 4, 6, 8. And when I multiply 6, you have 6, 12, 18, and whatnot. So I can see that 6 is a multiple, a common multiple of both. So I'm going to multiply the whole equation by 6. And when I do that, when I multiply the first part, this equals g over 6 by 6, the 6 totally cancels out. Divided by 6 and multiplied by 6, I'm just left with g, which is what we were trying to do in the first place. Now here, the 1/2, because this whole thing is in parentheses, it's being affected by the 1/2. So you don't have to actually multiply the things inside by 6. You could just multiply the number on the outside by 6. And 1/2 times 6, you get 3. So I'm going to bring everything else down. And now we have, one of those normal problems where we have to distribute. I got rid of all my fractions, which was great. I want to get all my g's to the same side so I can then isolate them. So I'm going to move this over by subtracting 9g. And when I subtract 9g on both sides, it does what I want it to do. It will cancel out on this side. And now all of my variables are on the same side. I have a positive 1g minus 9g, and that's negative 8g. And my last step is going to be to isolate the variable. So it's being multiplied by negative 8, so I'm going to divide by negative 8 so that I end up with 1g, or just g. And then if I divide by negative 8 here, negative divided by negative is a positive. So I end up with a positive 6/8, which this reduces to 3/4. And obviously 75 hundredths, I'll write this up here, is also totally fine. I hope that helps, and just let me know, and have a great weekend.